Hi, welcome to my video on proofs with double congruent triangles. Let's do some proofs with double congruent triangles. These are very important when you go to do proofs on the topic of quadrilaterals, like parallelograms, rectangle, rhombuses, etc., etc. So let's start number one. We have a diagram, as you can see, and we're given that WE, which is this long side right here, is equal to FT, which is this one, and PV and TE bisect each other. So if they bisect each other, that means OP is equal to OV, OT is equal to OE because they bisect each other. And we have to prove that angle W equals angle F. Angle W is right here, equals angle F here. So we need to prove W equals F, we need to probably do it with a pair of congruent triangles. So W is in the triangle TWE and also in the triangle ETF. So we need these two triangles equal or congruent. So, but we only have this side and this. So if we look at WTE and FTE, let's just look at these two and just see what we have. WTE and FTE. We want to prove that W equals F, so that's these two, but we have that WE, which is this side, equals TF, which is this side, and we have TE equals TE, common side, but we don't have anything else. We don't have any angles. So we have to prove there are more triangles there. So we have to probably prove the first pair of triangles, another pair of triangles congruent, and use that part or their parts that's in this one. So how do we do that? Well, I see that we have these two equal. These two segments are equal here. And we have angle 1 is equal to angle 2. So we can prove that POE is congruent, triangle POE is congruent to P triangle POE is congruent to VOT by side, angle, side, side, angle, side. And we can use their parts. So we can say that angle 3 is equal to angle 4, CPCTC. And now we got angle 3 is right there, and angle 4 is right there. So now we got these two triangles congruent by side, angle, side again. And that gives us W. So we're doing a double congruent triangles. So we have WE equals FT given. And we could have put it all in one. I just kept it separate there. They bisect each other. And that's also a given. And because they bisect each other, that means that PO is equal to VO and EO is equal to TO. And that's the definition of segment bisector. They bisect each other, so they cut each other in half. Now we have angle 1 equals angle 2. So we have these two sides. These are equal. These two are equal. So we have angle 1 equals angle 2. And that's a VOAT or a VAT, vertically opposite angle theorem, or vertical angle theorem. That makes the two triangles, triangle POE, congruent to triangle VOT, and that's a side angle side congruency. And as a result, we have angle 3 equals angle 4. So in these two triangles right here, POE and VOT, angle 3 is equal to angle 4 by corresponding parts of congruent triangles congruent. And now we have WEFT is given. We have angle 3 is equal to angle 4. So now we have to go that TE is equal to ET, common side. And now we have triangle TWE is congruent to triangle TWEFT, and that's, what do we have? We have this side with this side, and this is, should mark them with these, that's 2 strokes, so we mark these with 3 strokes, and we have to mark those with 4 strokes. And the triangles are side angle side congruency, and that makes angle W equals angle F. So if these two triangles are congruent by side angle side, then W is equal to angle W is equal to angle F by CPCTC. So notice we have to prove two triangles congruent. Hopefully it's making sense, but the more proofs you do, the better you get. Here we go. Let's try another one. We have B here. And again, notice we have overlapping triangles and we have to prove. Now, notice we have OA, this long side, equals OB. That's a given. And we have perpendicular here, so that's two right angles, perpendicular here. AX is perpendicular to OB, so we got two perpendiculars there. And we have to prove that VT equals XT. So these two sides are in these two triangles. So let's have a look at, can we just do that like this? So there's V, A, X, B. So we have a right angle there and a right angle right there. There they are. They're equal. We have this angle equals this one. They're equal. So we have two angles in the triangle. So we can get a side. We need a side. But we don't have V. We got to prove that T is here. So we got to prove that these two sides are equal. But we can't get any more sides, so we have to use another pair of triangles. So I can see, let's do this, and this one. So I got an O, A, X, and an O, V, B. So these big triangles, we have OA equals OB, that was given. We have the angle right here is a right angle, and this is a right angle. So we got an angle, pair of angles equal, pair of sides equal. If we had another side or another angle, but as you see, first time we did it in the proofs, we have this angle O equals this angle O. The angle is common. So that means these triangles are congruent by S angle, side. And how do we get to, that makes, we want to get to the sides, so we still can't, that means we can get this angle here equals this one, and that's the angles in the triangle, but we still can't get to the sides. But we know that if these sides are equal, we got OX equals OV, so if OX can equal OV belonging to these two triangles, then we can, because OA and OV, if we subtract them, we'll get AV and XB. So, and that will give us these two triangles congruent, so therefore this VT equals XT by CPCTC. So here we go. Number one is OA equals OB, and I could put all of them in the same step. We got BV is perpendicular to AO, and we got AX is perpendicular to BO, and that's the givens. And as a result, we have to look at these two triangles. So we have, because they're perpendiculars, let's go 1, 2, 3, and 4. Because they're perpendiculars, then in this triangle, which is OXA, that's angle 3, OVB, that's angle 1. So because they're perpendiculars, we have angle 1 is equal to angle 2, or should I say angle 1, let's do angle 1, angle 2, angle 3, and angle 4 are right angles. Definition of perpendicular lines or segments. Number 3, angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4, because all right angles are equal. And now we have 3 is equal to 4. We got, okay, 3 is equal to 4. We got these two sides equal from right here. So now we need angle O is equal to angle O, because it's a common angle. Normally we dealt with a common side before, but this is a common angle in both triangles. So that means we now have the triangle AOX congruent to triangle BOX. And the reason is angle, side, congruency. So based on those being congruent, we have OX equals OV, and that's a CPCTC. So if these two triangles are congruent, OX equals OV. So we have that OA is equal to AV, put it on W, AV plus VO, and OB is equal to BX plus XO, and that's the segment addition property. And as you can see, that AO is made up of AV, and VO. So as a result, we have AV plus VO is equal to BX plus XO, and that's the transitive property. So OA equals OB, OA is right there, OB is there, they're equal. Therefore, this AV plus VO equals BX plus XO, and that's the transitive property of equality. And as a result, I have that OX equals OV, so that means that A B equals BX by subtraction, property of equality. And so now we have, let's see what we have in this triangle here. So we have angle 2 equals angle, right here we have angle 2 equals angle 4. We have angle A equals angle B, and we have AV equals BX. So we have those two triangles congruent. So triangle AVT is congruent to triangle BXT, and that's an angle side angle congruency. And that leads us to number 11. Because the triangles are congruent, as you can see that VT equals XT. And that's CPCTC. Again, you got to look it over and prove one triangle congruent, use their parts to get the other triangles congruent. Okay, we have a couple more proofs to do just to see how you're doing. But don't forget, you can pause your video and work them out. If you do your own proof first. And statements, reasons. I didn't put that down, so I'll put it down now. Statements and reasons. Okay, we have this diagram. We're given that WB is so WB is parallel to CE, so they're parallel. And remember, when they're parallel, we have angles equal. So it looks like I can have this angle equal to this one, alternate interior. I could have this angle right here equals this one, alternate interior, or I could have this one equals to this one, alternate interior, because these two are equal because this is a transversal, and these are equal because this is a transversal, AS. Now we're also given that angle W equals angle C, so I'll mark that. And we're given that WA equals CS, but WA is only part of a triangle, part of a side. So how are we going to do it? Let's see. I got to get at, and I want to prove that EB bisects AS. So EB bisects AS, because it could be a bisector, that means that TA is equal to TS. So to get TA equals TS, I have to use triangle ATB and STB. So if I can prove ATB triangle congruent to STE, then I have I proved a bisector. But I don't have any sides. I got this angle equals this one. I got this angle equals this one, but I don't have any sides pertaining to ATB and triangle STE. So So that means I have to go and look at the larger triangles. Let's see. Here we go. So I got a W, E, B, and a B, E, C. So I'm given parallel lines like this. So that means that I have this angle. I'm going to call it 1 equals 2. There's angle 1. ABT or ABE, ABE. And this is 2, which is BEC. So I can get those two angles equal. I have WA equals, I have this angle equals this one, given. And I notice I have, as a parallel right there, this side is equal to this side common. So that means that these two triangles here are congruent by AS. And now I can get their parts. Here we go. So if I can prove that these are congruent, which I can, AAS, then I got WB equals CE. So I can pick up that if these two are equal, if WB equals CE, and I know that WA equals CS, I can subtract and pick up AB equals SC, and it'll give me my two triangles congruent here. So again, you got to be very careful on double congruent triangles. So we have WB is parallel to CE given. So what I should do, I got those triangles, so now I should draw the other pairs because we're going to use them. So SNE, S, A, B, T. This is the triangles that I have to get the bisectors in. So to get the bisector, I'm proving that these two triangles are going to be congruent. And so I have angle 1. There we go. Parallel lines gives us angle 1 equals angle 2. And that's PLT, parallel lines. And they're all PLTs. Two lines of parallel corresponding angle, alternate interior angles are equal. And number 3, I have, now we're dealing with 1 and 2 here. I'm dealing with these two triangles now. So I got angle W equals angle C by given. And I got BE equals EB, common side. BE is in both triangles. So now I have the triangle W, B, E, W, B, E is congruent to C, E, B. And that's an angle side. Congruency. And as a result of that, we have WB is equal to CE. That's a CPCTC. These two triangles are congruent, so WB equals CE. And WB equals WA plus AB. And CE is equal to CS plus SE, and that's the segment addition postulate. And as a result, WB equals CE, WB equals CE. That means that WA plus AB equals CS plus SE. And that's transitive property. Notice that WB equals CE, there they are, right? They're equal. So therefore, WA plus AB equals CS plus SE. And we have, let's see, I have those two equal. So that means that AB is equal to, we have the triangles congruent. So we have, let's see, we got those. So WA is equal to SC as a given. Notice, given WA is equal to CS given, and hence WA equals CS, so that means that AB is equal to SE by subtraction. These are the properties we learned in the earlier subtraction property of equality. So that makes that we have, let's see, we can have now, if we want, we can have 3 is equal to 4 right there. Notice angle 3 is equal to angle 4 by VOAT or VAT, vertically opposite angle theorem. And number 12, we have the triangle ATB is congruent to triangle STE. And notice we have, there's 1 and 2, and we have AB equals SE, so that's a angle side. Congruency. And we're trying to prove the bisector, so we have AT equals ST by CPCTC. These two triangles are congruent, these two segments are equal, and because they're equal, that means that EB bisects AS. Definition of a segment bisector. So it takes a bit of looking, and to be careful, make sure you support, each statement is supported through the proof. And again, another double congruent triangle. And the final one to do here is this one. Again, pause the video and work it out yourself if you can. See if it makes sense. Now, number 2 here. O is the midpoint of AB and RX. And we got to try to prove that YA, which is this one, we put a little question mark, is equal to SB. A little question mark. Now, how do we get it? Well, we have this angle is equal to this one. We have, let's see, O is the midpoint. So O is the midpoint of AB, so that means OA equals OB. and O is the midpoint of Rx, so that means OR equals OX. So in terms of trying to get this side here, I got triangle YAO and SBO, these two triangles right here. I have a side, I have an angle, but I have no more angles. I don't have any more sides, so I have to do it with another congruent triangle. So here we go. And I have these two equal. OA, OB are equal. OR, OX are equal. And I have this angle right here. I'm going to call it 1 and 2. They're equal by VOAT. So that means I can deal with this triangle, and I can take triangle AOX and BOR and get them congruent by SAS and use their parts. I can use this angle here, 3 is equal to 4, and I can say 3 is going to be equal to 4 CBCTC, therefore 5 is going to equal 6 by supplement angles, and now I have an angle, a side, and an angle. So I have let's see, I'm going to put a 7 there, lots of work. So here we go. Remember now, I got to put all these numbers in to make the angles easier. So O is the midpoint of AB and RX given. So that makes AO equals BO and RO equals XO, definition of a midpoint. The midpoint is in the middle, it makes the two segments equal. And as a result, I have angle 1 equals angle 2, angle 1 equals angle 2, VOAT or VAT, vertically opposite angles there. So that makes the triangle AOX congruent to triangle BOR, and that's a side, angle, side, side, angle, side. Congruency. And now we have to say that angle 3 equals angle 4, CPCTC. So angle 3 and angle 4 are in this triangle, and this one they're congruent or equal. Number 6. Now we have angle 3 and angle 5 are linear pair. We can also have angle 4 and angle 6 are a linear pair. Definition of a linear pair. Linear pair is two adjacent angles that form a straight angle. That means that angle 3 is supplementary to angle 5. Angle 4 is supplementary to angle 6. And that's a straight angle. Notice that's a straight angle right there. So they add up to 180. And that's a straight angle right here. They add up to 180. So that means if 3 is equal to 4, that means that angle 5 is equal to angle 6. SAT, supplement angle theorem. Supplements of congruent angles are congruent. And so we have AB is bisecting, so they're equal. AO equals BO. We got angle 5 equals angle 6. And now I can have angle 7 equals angle 8 by VOAT or VAT. Two segments intersecting, cutting, then the vertically opposite angles are equal. So that makes the triangle AOY. AOY is BOS. And that's an angle side angle. Congruency. And because those triangles are congruent, then I have YA equals SB. And CPCTC. For double congruent triangles. Can be confusing, but you just need more practice. The more practice you do, the better. Because you'll use these double congruent triangles in your quadrilateral proofs. That's another unit coming up later. And if you like my video, click on the like button, subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing the video. Bye-bye.